This tutorial demonstrates how to do a magnetic compensation flight. There are 4 sections. Introduction. Magnetic compensation is briefly explained. Flight preparation. We talk about how to prepare for compensation, what you need to know and do prior to flying. Compensation maneuvers. The details about what needs to be done during the flight. Common mistakes. We discuss the common mistakes that can be made during the flight. The purpose of a compensation flight is to gather information about how the movement of the plane affects the magnetic noise. This information is then processed and compensation coefficients are generated. The coefficients are then used to remove the movement noise from the acquired magnetic data. The compensation procedure is done in the following sequence. First, motion data is acquired. Second, compensation coefficients are generated. Compensation coefficients are either used during the survey to correct the incoming data in real time, or they are used to correct data in post-processing. The compensation flight requires that the following specific steps be taken in preparation. The normal data acquisition program should be run with the same sample rate as the one to be used in the survey. 10 Hz sampling and 2 Hz bandwidth is recommended. Aircraft systems that consume large amounts of power should be turned off. Air conditioners can be placed in a mode where the compressor and fan systems are continually on and do not cycle. All other equipment that would normally be on during the survey should be in normal operating conditions. The autopilot must be turned off and the aircraft flown manually. A flight log must be prepared. More on this later. During the compensation flight, the plane will need to do 3 types of maneuvers. Roll maneuver. The wings of the plane move up and down. The range of motion is 10 degrees from peak to peak. Yaw maneuver. The tail moves left and right. The range of motion is 5 degrees from peak to peak. Pitch maneuver. The nose and tail of the plane move up and down. The range of motion is also 5 degrees from peak to peak. Each maneuver should be performed over a 5 to 10 second period. The maneuvers will need to be performed for 4 headings. The 4 headings depend on the headings of survey and tie lines. 2 compensation headings must be parallel to the survey lines, and 2 headings must be parallel to the tie lines. Parallel lines must go in opposite directions. The shape of the flight path should be close to a square. For each heading, you will need to do 3 maneuvers of each type. This is 9 maneuvers in total per direction. The maneuvers must be done in a magnetically quiet area at high altitude, 2.5 kilometers or 8,000 feet above ground. Be ready to write in the flight log. This is how a flight log should be organized. The start and end fiducial numbers of all major events are indicated. Name of the file that contains recorded data is indicated. Time and date of the flight are written. Include additional information if needed. As you can see, the east maneuvers were done from 1394 to 1445 fiducial in this example. When the desired altitude, location, and heading are reached, you are ready to begin the maneuvers. We start the procedure with 3 roll maneuvers. Notice how the maneuvers are very smooth. When finished with the roll maneuvers, move on to the yaw maneuvers quickly. The maneuvers should resemble the sine wave. Move on to the pitch maneuvers. After the maneuvers are complete, indicate this in the flight log and do the maneuvers for the next direction. The order of motions is not critical. However, it is a good practice to keep them consistent. During a survey, the compensation flight should be done every 2 weeks or any time a major magnetic component is changed. Frequent compensation flights keep the compensation coefficients up to date. Certain mistakes will make the data gathered during the compensation flight useless, and the compensation flight will need to be done again. Amplitude is not consistent for each maneuver. You need to keep the range of motion of the plane steady. Period is not the same for each maneuver, and motions are not symmetrical. Keeping motions as uniform as possible is very important. Rough movement of the plane generates detrimental magnetic noise. It is crucial to make the movement as smooth as possible. Another mistake is when there is an accidental change of plane's direction or altitude. Changes in altitude should not be greater than 50 meters. These examples display the mistakes in their most extreme form to convey the message. Even very small mistakes of this kind could negatively affect magnetic compensation. This concludes the demonstration.